So drainage water recycling is the capture of water either in a pond, reservoir, or a drainage ditch, and then putting that water back on when we have deficit or we need irrigation or we have deficit water conditions. The main goal is to improve yield, but also there's a benefit when it comes to water quality as well. The Conservation Showcase that was established here is a tremendous partnership between the Missouri State NRCS as well as our Missouri Land Improvement Contractors here in the state of Missouri. That's to feature new, innovative conservation practices, advance them to the field scale, or if there's a new practice that we haven't seen in the state of Missouri, demonstrate the efficacy of that practice. The soil types that we're going to see are clay pan soils, primarily. These clay pan soils have an impermeable layer that's about 18 to 24 inches below the soil surface. Above that clay layer, those soils are highly permeable, and then they reach this clay layer and they're very impermeable. The water resources here at the Grace Greenlee Farm include surface water runoff as well as subsurface drainage water. The subsurface drainage water encompasses an area that drains about 40 acres, and then the watershed that contributes to our reservoir is about 150 acres. The reservoir at the Grace Greenlee Farm is about 13 acres in surface area. Typically, we see peak rainfall occurring in the springtime from about mid-April to mid-May, and again in the fall from September to November, and that's when we'll see a lot of water contributions to our reservoirs that are used for drainage water recycling. That's typically when we see a lot of nutrient loss as well. And then during the summertime, we usually run into a water deficit, and so that's why it's important to have water at our disposal through these drainage water recycling systems so that we can provide water in a timely manner where we run into these deficits.
The site design was done by the NRCS. Over 3 years, we had multiple visits out here on site and with NRCS and offices. They could actually do design work, and they would come out here and lay this all out and do benchmarks, elevation points. They could then take it back into the office where they could put it on a flash drive or a ROM drive, so we could actually install this in on the machines. So what was a benefit to us, we knew we had a short time. So with them being able to put that on a thumb drive, we could install it on our machinery that we had out there, and it would tell us exactly the elevation and where to place the soil that we needed to go when we was building the structure. We came over on site that first day just to meet with NRCS to make sure that the site was basically situated correctly, the benchmarks were put in right, going over the plan, so we all had a basic understanding of what and where the dirt placement was going to be, the pipe placement, trying to get the welder on site to weld the pipe together. So at that point, we started on a Friday afternoon just to try to get our heads together, to try to get everything involved and get everything kind of lined up to make sure that we had everything that we needed at that point. The first 2 days was what we call stripping. We had to take the topsoil off. Through the NRCS specs and the soil type they wanted us to use, we had to get to that clay layer. So we actually had to remove, I'm going to say, an estimated 10,000 yards of topsoil. We had to place that in our outside of our borrow areas and level it down. That was kind of an unforeseen event. We was hoping that we would not have to move quite as much. But once we got down to that clay layer, that's when we could actually start hauling for the structure at that point. With the completion of the structure, it doesn't look like there's that much soil that's been moved, but we had almost 40,000 cubic yards of material that we moved in that 8-day time frame. This is almost a 13-acre lake that we have behind us. So what we were able to do when we took that topsoil off, we were able to layer that in the existing ditches and low areas. So now they'll be able to, in future, utilize those those ditches where we put the topsoil as productive ground. So when we look over the whole site, the loss out of production is going to be minimal. It's going to probably be, I'm going to say, around that 6 to 7 acres instead of the whole 12-acre area. So it's not only a benefit to have the water, but it's also a benefit to be able to use the topsoil and gain them some more production in the ground. I'd say the biggest issue we had was on the core trench. They had done the soil samples that they knew that there was some soil that was not the best. They were afraid that it was going to permeate through the structure. So we did have to go down like an extra 6 feet to core that out, to put the clay layer back in so that we would not lose any of the water out of the site.
When it comes to managing water inflow and water outflow, a lot of that is tied to rainfall contributions. And since we're dealing with a fairly large watershed, and a lot of that's surface water runoff, we're seeing the reservoirs fill up and recharge very quickly. Outflow, we're primarily lifting that water up to our irrigation system, whether that be subirrigation, whether that's subsurface drip irrigation, or an overhead irrigation system. Okay, and most of the systems that we're going to see at our research facility are sub-irrigation systems. The irrigation system that we're utilizing is pressurized, but the main reason is so that we can measure the amount of water that goes into the control structures. So it's a monitoring reason for pressurizing it. A sub-irrigation system, we've been utilizing observation wells to monitor the water table depth, okay? And that allows us to see the water level in the soil profile above and then between the tile lines. So we pull the water table up, okay, and we leave it as high as possible throughout the growing season. Now, that makes it susceptible to saturated conditions if we get a lot of rainfall. So we have to be very responsive to when a rainfall event takes place, and it would need to be moved into drainage mode. Currently, that's manually changed, and it's a lot of work. And there's a lot of mechanized systems that are available, and that's one of the goals here at this site, is to feature some of that new technology that we can tie a sensor in the soil to a automated system that can adjust our slides and the control structures, and ideally do that remotely, so that if it's raining here, we can put it in drainage mode, and then we can put it back into controlled drainage or sub-irrigation mode shortly thereafter. I see drainage water recycling as being more resilient when it comes to crop production. Okay, that resiliency is going to be important as we see variable rainfall patterns. We've seen a lot of extremes when it comes to a lot of precipitation, and then on the other end, drought situations. So when we're looking at our baseline here in Missouri, because we're not a major subsurface drainage state, is no drainage. Okay, and so when we add drainage to these soils, over the last 18 years, we've seen a 20% increase in corn grain yields and a 20% increase in soybean grain yields. Okay, and that's the drainage component. Okay, then we layer drainage water recycling on top of that, and we've seen a little over a 40% increase in corn grain yields and about a 29% increase in soybean grain yields with drainage water recycling compared to no drainage. The other thing is that when it comes to water quality benefits, we're keeping those nutrients. Ultimately, we want to keep the nutrients in the field, okay? But if they are removed in the water resources, or if they are in the water resources, then we can capture those on farm and then reutilize those as well. I think that has a huge societal benefit as well, because we're keeping them out of the Gulf of Mexico or Lake Erie when it comes to phosphorus issues in Lake Erie, or if it's nitrate issues to any water resources. new alternatives, new opportunities to diversify the crop or diversify the farm production systems. We have a lot of livestock in the region too, and if we're utilizing like a cover crop on our drain fields, we can then utilize that as a forage source then too. And I think we can get a greater intensification of our soil resources using our drainage water recycling technology.